Good evening and welcome to part 2 of my double shot of content today on the Angry Astronaut. We're going to venture into an area that I really haven't ventured into very much at all, and that's the field of exoplanets. Even though I may talk about exoplanets in the course of discussing the possibility of extraterrestrial civilizations, that sort of thing, I've never really talked about exoplanets for their own sake. And instead of talking about Earth-like exoplanets and the endless search that we're involved in trying to find a planet that may be similar to our own, a planet that will be pleasant and, inviting, waiting for us to colonize it, I would rather talk about some of the most horrific planets in the galaxy. Now, of course, we've got our own collection of horrific planets right here in our own solar system. Venus is very much like hell, incredibly high temperatures, the temperatures of molten lead actually at its surface. Acid rain, actually sulfuric acid clouds, and on top of that also, of course, an unbreathable atmosphere and an enormous amount of pressure sufficient to crush anybody that would be exposed to it almost instantly. It's very difficult to create a spacecraft that can even survive for more than a few minutes on the surface of this very hostile world. And of course, we have our collection of other worlds in the solar system that are pretty formidable as well, but none of them really compare at all to the horrific and deadly places that we're going to be discussing in this video. And also, I'm going to be covering why we might, as a species, visit one of these planets one day anyway. So get ready for a bit of a spooky and disturbing episode of The Angry Astronaut coming at ya right now. So one of the first questions that may have occurred to some of you is, how the hell are we going to visit planets like this anyway? All of them are many light years away from the sun. It would take forever for us to reach them. Well, that's mostly true. However, if we were to utilize, say, some kind of antimatter propulsion, and yes, that is a thing, something that we could, at least in theory, build over the course of the next couple of centuries. And if you're interested in that, by the way, I have the video linked at the end of this video. However, with this type of propulsion, we could, at least in theory, reach speeds of up to 92 to 93% of the speed of light. Now, this still means that it would require centuries for us to reach our destination, depending, of course, on the distance, but as far as the travelers on the ship are concerned, a lot less time would pass because of the effects of time dilation. So just keep that in mind when we're talking about these planets and their distance and the potential of us visiting them someday in the future. The first planet is going to be the most violent one, and frankly, one of my favorites. It is 217 light years away from Earth, and the name of the planet is really exciting, HD 80606b. Yeah, if you're going to deal with exoplanets, you're generally dealing with unexciting names, at least until somebody else gets the responsibility of naming them. So as you can see from this NASA educational video, this planet is unusual not in its size or its configuration or anything like that. It's a hot Jupiter, which is a pretty common thing in the galaxy, but instead in terms of its orbit. Highly elliptical. At apogee, it orbits up to 0.876 AUs away from the star, or 131 million kilometers, but at perigee, it's 4.5 million kilometers away from the star. Unbelievably close, even as far as Mercury or planets like that are concerned. Crazy close. And during the time that it orbits closest to the star, it's also traveling at an insane velocity velocity, 47.3 kilometers per second. The orbital eccentricity of the star is very extreme, similar to that of Halley's Comet, and very unlike a planet, but the most amazing thing about this planet is how rapidly it heats up when it's making its closest approach to the Sun. We're talking an increase of temperature from about 800 degrees Kelvin or 500 degrees Celsius to 1500 degrees Kelvin or 1200 degrees Celsius in just 6 hours. And that kind of radical temperature increase creates some very strange and very violent side effects. One of the most significant of which is something called a shockwave storm. Computer modeling of the planet predicted that since it was heating up over 500 degrees Celsius in just a matter of hours, storms would ripple out from the point facing the star with incomprehensible wind speeds. We're talking 18,000 kilometers per hour, about the fastest wind speeds that have ever been measured anywhere in the universe. By way of comparison, Jupiter, which has legendary wind speeds, well, the so-called king of the planets is only clocking about 600 kilometers per hour, and even Saturn, that really has legendary wind speeds, is only about 1,500 kilometers per hour. Absolutely pathetic compared to the shockwave wind speeds on this very terrifying planet. So why the hell would we want to go here in the first place? Well, it all depends on how we are going to be traversing the galaxy. If we are utilizing antimatter propulsion, you may recall from my previous video on the subject that antimatter can be found in greater abundance around planets that have strong magnetic fields. And a planet like this one, with 4 times the mass of Jupiter, is likely to have an incredibly strong magnetic field with a great deal of antimatter to harvest, which means the ideal approach would be to come at this planet when it's at a relatively safe distance from its star and then harvest the antimatter quickly enough before it gets too close to the star and starts generating those crazy shockwave storms. And given the fact that this planet comes so incredibly close to its host star, it's also possible that it actively interacts with the star's magnetic field, in which case it may pick up more antimatter from the star itself. It's hard to say for certain, but it's very possible that this planet is a treasure trove of antimatter, which would be extremely valuable to any ship traveling to the system. And keep in mind, this is a G-class star, similar to our own. Aside from this crazy hot Jupiter, it could theoretically have habitable planets orbiting a bit further out beyond the gravitational influence of this massive gas giant. If that is indeed the case, there may be more than one reason for us to visit this strange system in the future. But now it's time to go to an even more frightening place and visit a planet called Poltergeist, a so-called zombie world known to scientists as PSR B127 plus 12b. So why do they call it a zombie world? Well, for the longest time, at least ever since we discovered supernovas and pulsars, it was believed that a supernova would utterly destroy its planetary system, especially any planets that were close to the star. As a result, one would not expect to find any sort of planets in a pulsar system. However, that is not the case. As a matter of fact, most of the time, pulsars have some sort of planetary system. How is that possible? Well, it's been determined, interestingly enough, that after a supernova occurs, a new planetary formation cycle begins, in which case you have new planets evolving around an active pulsar, which is probably one of the worst places that anybody could possibly be because of the colossal amounts of electromagnetic radiation generated by these strange phenomena. This planet and its two companion planets, Thibiter and Draugr, and I have no idea if I pronounced that correctly, orbit at a lethal distance from the pulsar, less than 0.2 of a single astronomical unit away from the pulsar, definitely close enough to be continuously blasted by radiation. Its orbital period is only 25.3 days, and it is undoubtedly the most lethal place that you could possibly go in the galaxy, with the exception of a black hole. Other than that, I really can't think of any other place that could possibly be more dangerous than this close to a pulsar. So why the hell would you ever want to go here? Well, for one important reason. The pulsar in question is called a millisecond pulsar, and it's incredibly useful for navigational purposes. So useful, in fact, that a couple of astronomers have recently theorized that alien civilizations may actually be making use of pulsars, tweaking them so to speak, in order to make them more useful for navigational purposes than they already are. And before you scoff at this notion, I recommend you check out a video that I have linked at the end of this video that contains also the papers that make this claim. It's very compelling stuff, but if it's requiring some kind of tweaking or stellar engineering in order to make these pulsars useful, it may require some further work in the future that our species may become responsible for. If the alien civilization that started this entire process becomes extinct, or they assign this job to us in the future, who can say? But there may be a reason that we have to visit this horrible system in order to make interstellar navigation a practical thing. But let's move on to this pretty blue planet. This can't be a deadly world, can it? Well, it absolutely can, because in spite of its relatively attractive appearance, blue always looks nice, doesn't it? As a matter of fact, it looks like a pretty blue marble of some kind, but it actually isn't. It's a planet that's orbiting crazy close to its sun and being bombarded by solar flares on a regular basis. The planet is called HD 189733b, and it's another hot Jupiter, and this one is insanely close to its host star, only 3% of an astronomical unit away, or roughly 3 million miles or so. Its mass is a little bit more than Jupiter, 1.13 or so, and it only takes 2.2 days to complete one orbit around its star. So why the hell would we want to go here? We're talking about temperatures in excess of 1100 degrees Kelvin and wind speeds of about 8,000 kilometers per hour, a completely horrific place. However, there's something to consider when we're talking about the rest of the system. Keep in mind, this gas giant is orbiting incredibly close to the K-class star, and the habitable zone of this star is actually pretty sizable. And not only that, the system is only 64.5 light years away from our star, in which case you could journey there, assuming that you had a pretty fast ship and decent time dilation effects, at least as far as the crew would be concerned. And in addition to that, we have detected very unique and unusual chemical processes happening on this planet, or rather in its atmosphere. The most disturbing thing about it is the fact that we think there's molten glass in the atmosphere being blown horizontally at thousands of kilometers per hour. And by the way, if you reach the night side of the planet, the temperature might drop sufficiently for that molten glass to become solid glass, an absolute shitstorm of death. I'm not sure which would be worse, being subjected to a pulsar's radiation, which would kill you in seconds, or being subjected to a hailstorm of tiny knives, which would rip you to shreds within seconds. Kinda hard to say, but it's a little scary to think about the fact that these things actually exist in our galaxy, and we aren't quite done yet. Can you see this planet? No, you probably can't, at least not very well. Let me take the brightness up a lot. You know, given how common hot Jupiters are in our galaxy, we're very lucky that we don't have one of these things in our solar system. This particular planet, called TRES 2b, is a gas giant that absorbs virtually all the light that hits it. It is the darkest object in the universe, at least that we've been able to observe. Black holes are darker in some ways, but the debris and stellar material that orbits most black holes burns very brightly before it gets swallowed up, revealing where the black hole actually is. This planet is not so generous. It absorbs 99% of the light that strikes it, the lowest albedo of anything we've ever seen, and we have no idea why. If you were in the clouds of this gas giant, you would not be able to see a damn thing. You would be completely engulfed in an inky blackness. Like most hot Jupiters, it orbits very close to its star, which, by the way, is a G-type star, very similar to ours, that has a large habitable zone. Again, another suitable system for colonization, although it is 702 light years away, so perhaps something to be visited far off in the future when we have a sizable interstellar civilization. The temperature in the clouds of TRES 2b are also incredibly high, as one would expect in a hot Jupiter. However, this is where the similarities end. We really don't have any idea as to why this planet is absorbing so much light. Now, it has been theorized that there are chemicals like vaporized sodium, potassium, or titanium oxide in the atmosphere that might be absorbing a lot of the light, but that doesn't even begin to explain why this planet would be absorbing this much light. It is a very, very strange phenomena, a unique phenomena throughout the galaxy, and one that should be studied in detail. And if we ever colonize this solar system, it's very likely that we are going to study this planet, even though it's a terrifying place, to say the least. Although there are dangerous and foreboding worlds in our solar system, none of them compare to some of the horrors that await us out in the rest of the galaxy. Planets that have shockwave storms, that are blasted with insane amounts of radiation, and planets that devour every bit of light. And one day, if our civilization is lucky enough to survive, we may visit some of these places and encounter other civilizations that are also in the process of exploring them. And let's hope whatever life we find out there is not as terrifying as some of the planets. Smash that like, hit that subscribe, please hit those notification buttons as well, and check the description for various ways to keep this content coming. And as always, stay angry about space.